Climate change is warming water temperatures, creating acidification and marine oxygen shortages on a global level.
These climate-induced impacts are shifting breeding and migratory patterns, changing ecosystem dynamics and altering prevalent species and their populations.
This is creating uncertainty within UK fisheries and hampering their management as a result, as different fish need different climatic conditions to thrive. As water temperature in the UK fisheries rises, species typically found here, especially demersal species like cod, hake and haddock, move northwards looking for colder waters. In return, we get new species from southern, warmer waters off the Mediterranean. This is creating the problem of setting new quotas, new marine protected areas, as well as establishing selective fishing methods for these new species. Historical modelling of fish populations typically found in UK fisheries are thus becoming obsolete. Overfishing of cod in the 20th century led to stringent laws being in place. Minimum catch size was decreased from 35 to 30 centimetres, but due to epistemic uncertainty surrounding these new species, new quotas and size limits like these will be hard to reach for a sustainable outcome. Increasing water temperature is having a great effect on the migratory and breeding patterns of some pelagic fish. Fisheries that rely on these migratory fish, like the species mackerel, are left guessing as to where and when these species will turn up, as due to the increasing water temperature, typically breeding grounds around Cornwall and the south coast have shifted further northward towards Norway and Iceland to find colder temperatures. So how can understanding epistemic uncertainty allow us to implement laws and regulations that will create an environmentally friendly equilibrium for the UK fisheries?
Epistemic uncertainty relates to uncertainty deriving from a lack of knowledge or information and an effective lack of modelling.
Using evidence-based lexicons reduces the naive notions that different people have shared interpretations of what terms mean. These evidence-based lexicons tie in specific terms to numeric values and ranges. Providing a non-deterministic forecast of fish populations better describes people's, the recipients' views on the inferred uncertainty of any research project, and thus laws and regulations in place are more likely to be taken seriously and not breached.